All right, so now we're going to keep going with our transformations to just get into a little bit more specifics with how we are going to identify matching parts of the figures to ensure that they are in fact transformations. So I am on page 9 of your workbook. And again, anything I'm writing in blue, you should be writing down. You don't have to write down page 9 though. So just make sure they get into your workbook somewhere. So to start, they want to know, is this a translation, reflection, or rotation? Because it's a flip, it's going to be considered a reflection. And so they want us to draw an arrow to show how it was reflected. So I'm doing this in red, so please don't draw it. We wouldn't draw our arrow here because if I fold on this red line, it's not going to match up perfectly to the other figure. So we need to make sure that the line we draw is right equally between the two shapes. So we should draw it right here and make it as straight as you can. And so before we talked about a horizontal flip or reflection, this is going to be a vertical reflection. And so next week, or next lesson, we're going to talk about reflecting over the y-axis. That's essentially a vertical flip, because if you think of your x and y axis, your coordinate plane, this is the y-axis, this is the x-axis. And so, yeah, that makes this a reflection. So at the bottom of this page, we have a couple more questions. So when figures are the same shape, you can identify corresponding parts between the figures. Angles in the same relative positions are called corresponding angles. Sides in the same position are called corresponding sides. And so let's look at the two figures and match up the corresponding sides. So if I look at line segment AB, let's actually write that down. When it's written this way, AB with the line over it, when you take geometry in high school, they're going to say line segment AB. Mathematicians are notoriously lazy, so they love any short way to say something that's much longer. And so line segment AB, I'm going to use a different color. AB is this side. Who would AB line up with if it was reflected right on top of this shape? It would line up with QP. So we would say AB and QP are corresponding sides. EF would line up with TU, so line segment TU. RS is this side. Notice how it's 2 units, 2 units. It would line up with CD or DC, which is also 2 units. UP is this little guy. He's 2 units. He would line up with AF or FA. Doesn't matter which order you name it. BC is 1, 2, 3, 4 units long. So is QR. And ST would match up with ED. So we're just matching up the sides with who they line up with. So same problem. How do we know that how do the lengths of the corresponding sides compare? How do we know? Well, we just looked at it. They are the same length. And the fancy word we're going to use for that this unit is congruent. This is like the word of the day, congruent. That means that they're the exact same length. And congruent has a cool little symbol. It's an equal to line with a little squiggly over it. That means congruent. Another notation, these two lines, those mean parallel. So when you draw 2 lines straight up and down, that means parallel lines. That's another symbol you'll see in geometry. It's kind of like learning a new language, honestly. So in figure A, B, C, D, E, F, AB is parallel to FE. Remember, parallel means that they're never going to intersect. You can write this saying AB is parallel to FE. And then in PQRSTU, PQ and UT are also parallel. How can we tell? Because they are never going to cross. So look at other parallel sides in our blue shape. Another set of parallel sides would be AF and BC. Those, remember, are corresponding sides to PU and QR. So see how these sides are parallel? Their corresponding sides are also parallel. So what do you notice about the corresponding pairs in figure PQRSTU? They are, oh, nope, I'm writing this in blue because I want you to write this down. They are also parallel. So in shapes that are transformations of one another, lines are the same, angles are the same, and parallel sides stay the same as well. All right, so we're flipped over to page 10. And they want to know, we started with our blue shape. They want to know which of these shapes are a translation, a rotation, and a reflection. So remember, with translation, the orientation doesn't change. So the only other shape who's got this pointy corner pointing north is HIJKL. So HIJKL, oops, sorry about that, is our translation. Reflection, I think, is next easiest. And so the reflection would be from the blue here. They did a horizontal reflection to get PQRST. So PQRST is our reflection. And our little line of reflection would be right in between the two, right here. And then ABCD is our rotation. We would actually call this a 90-degree rotation because it turned just one corner. So that's a 90-degree rotation, and we say it's 90 degrees clockwise because this is the way that a clock goes. Okay, so now they want us to identify corresponding angles, so matching vertices or corners. So we're just using PQRST to decide this. So let's use purple. V, that little pointy corner right there, matches up or corresponds with angle P. Oh, by the way, this is the symbol for an angle, a new notation. Let's see. Oh, I really should have written that in blue. So, angle. And we're just going to pretend this is in blue as well. Angle S is this little bottom corner. And so on our original shape, that bottom corner was angle Y. Angle Z is this angle kind of across from V. So that's going to be angle T. Angle X is going to match up with angle R. And angle Q, this little corner of a pretty big obtuse angle, is the same as angle W. So how do the measures of the corresponding angles in problem 4A compare? They are all the same. And remember, our new fancy word for that is congruent. So let's just list that very quickly right over here on the side. In transformations, lines are congruent. I'm going to use my fancy symbol. Angles are congruent. I'm being a true mathematician and trying to use my notation to my advantage. And then parallel lines, so parallel lines are the same. That's in any transformation. So let's finish up on the bottom of page 10. So in the last two problems, how can corresponding parts help you to determine that an original figure and its image are the same size and shape? So we basically want to see that they should all be equal. Actually, let me be more specific. Let's change this. Instead of saying they should all be equal, let's say the sides and angles that correspond should all be congruent. That's one part. And then the second part is parallel lines should stay parallel. So from the original to the image, the parallel line should stay the same. So question 6 you can do on your own. They just want you to do some transformation and make sure that all of the corresponding parts are equal. And we'll stop there.